Assalamualaikum, salam sejahtera and good day to everyone. For today, our group will be presenting about absorption refrigeration cycle. These are our group members, which consist of Aina Nurfaika, Muhammad Amirul Azwa, Amira Fatona, and Nurhusna Hafia. These are the topics we'll be discussing about today, which includes the introduction, process, application, conclusion, and reference.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aina Nurfaika, and in today's presentation, I would like to present about the absorption refrigeration cycle. So first thing first, what is thermodynamic? Thermodynamic is a science of the relation between heat, work, temperature, and energy, and it actually deals with a transfer of energy from the one place to the another place. So in thermodynamic, we actually has a law which is on the first law, the thermodynamic states that the change in a system internal energy is equals to the difference between heat added to the system and by its surrounding and work done by the system. So for the second law of thermodynamic, it actually tells us that heat does not flow spontaneously from a colder region to a hotter region. So it states that entropy of the entire universe as an isolated system will always increase over time. So what is thermodynamic in our daily life? Based on what I have explained before, thermodynamic on the first law is actually a chemical energy in fuel is converted to the mechanical work to move the vehicles, and for the other daily example, which is our body, will convert the chemical energy, which is the food, into the kinetic energy. So for the next is the second law of thermodynamic in our daily life, which is a cup of the tea cools down as heat moves to the surrounding air, while for the refrigerator work by using the energy to move heat from the inside to the outside against the natural direction of the heat flow. So the absorption is actually a process which a substance assimilates from one state to a different state, and these two states create a strong attraction to make a strong solution or mixture. The absorption refrigeration technology consists of generator, a pump, and also the absorber that are collectively capable of compressing the refrigeration vapor. So typically, they use a refrigeration and also the absorbent pair, which commonly is a pair of ammonia water or the water lithium bromide. So the absorption refrigeration cycle rule in thermodynamic is a technology where it's introduced to address the serious issue. So the absorption refrigeration cycle utilizes thermal energy rather than mechanical work to drive the cooling process. It also involves the refrigerant and absorbent with heat from a slow-grade source, causing the absorbent to evaporate and condense the refrigerant. By using the absorption refrigeration cycle, it actually can consume the low energy consumption, where the absorption cycles typically require less electrical energy than the traditional vapor compression cycle. In addition, this cycle can utilize low-grade heat, which can be driven by the low-temperature heat sources like waste heat, and making them suitable for renewable energy application. So it also can give advantage to the environmental, where this system have a lower environmental impact, especially concerning the global warming and also the ozone depletion.
Process absorption refrigeration cycle. Usually, in absorption refrigeration cycle, we will use ammonia. Ammonia is a refrigerant that gives cooling effect and refrigeration effect. And then water. Water acts as absorbent. Water has strong affinity towards the ammonia. So the ammonia water solution is formed and used to run the vapor absorption refrigeration process. What is refrigerant? Refrigerant is a heat carrier fluid and the latent heat properties to increase performance. The first process for this system is evaporation. In evaporation, the low-pressure liquid refrigerants enter the evaporator, where it absorbs heat from the surrounding and evaporates. And then is absorption. In this stage, the refrigerant vapor coming from the evaporator is absorbed by a liquid absorbent. Next is condensation. The refrigerant vapor, after being separated in the generator, it's passed to a condenser where it lose heat and become a liquid. And lastly is expansion. In this system, the high pressure liquid refrigerant from the condenser pass through a expansion valve or throttle valve, dropping its pressure and temperature. Why this process is important? For evaporation, this is where the cooling effect is produced. Heat is absorbed from the environment or a space that needs cooling. For the absorption, this replaces the function of a compressor in vapor compressor system. The absorbent pull in the refrigerant vapor, create a strong solution. Next is condensation. Why this process condensation is important? Because this phase change from a vapor to liquids release latent heat to the surrounding, often via cooling water or air. And lastly, for expansion, this prepare a refrigerant to evaporate and absorb heat in the next step. I will tell you the thermodynamic process for every process in this absorption refrigeration cycle. First is endothermic process. Refrigerant evaporates at a low temperature and pressure. This is for the evaporation process. And next, absorption process. The thermodynamics process is exothermic. Heat is released, require cooling water to remove the heat of absorption. And then another exothermic process. Temperature is kept constant during the phase change at a constant pressure. This is for the condensation. And then thermodynamic process for the expansion and exothermic process. No heat exchange but pressure drop.
For this slide, I'm going to explain briefly how ammonia water flows in absorption refrigeration cycle. We start at the evaporator. Here, liquid ammonia evaporates. It absorbs heat from the refrigerated space, turning into a gas. This absorption removes heat, effectively cooling the space. This step is just like the cooling part of a regular refrigerator. The ammonia vapor then flows into the absorber, where it mixes with cold water. The water absorbs the ammonia gas, forming an ammonia water solution. This step captures the refrigerant and prepares it for the next cycle. The ammonia water solution is then pumped to a higher pressure using a small pump. The energy used here is minimal compared to a traditional compressor, making the system energy efficient in the right condition. Next, the pressurized solution enters the generator. A heat source such as gas flame or solar heat heats the solution. This causes the ammonia to boil off and separate from the water. The ammonia vapor now flows to the condenser, where it releases heat to the environment and condenses back into liquid ammonia. This liquid ammonia passes through an expansion valve, which drops its pressure and temperature, preparing it for the cooling cycle again. The low pressure liquid ammonia then re-enters the evaporator, where it absorbs heat from the space to be cooled, and the cycle continues. The absorption refrigeration cycle uses a thermal compressor, replacing a mechanical one to move heat and create cooling, making it ideal for all grid or load electricity application. Next, the coefficient of performance for refrigeration system is a measure of their efficiency, defined differently for general refrigeration system and absorption refrigeration system. Definition: the ratio of the heat removed from the reservoir, cooling effect QL, to the net energy input, W net in, required to achieve that cooling, COP, are equal to QL over W net in. The ratio of the quantity of cooling power produced in the system to the quantity of heat applied to operate the system. And the COP for absorption refrigeration cycle typically ranges from 0.5 to 1.7. This COP vars is the formula based on temperature. where Tj is temperature of the generator, Ts is temperature of the surrounding, Ta temperature of the evaporator.
Type of absorption refrigeration cycle. First is ammonia water cycle. Absorption is based on the principle that ammonia vapor dissolves in water, lowering vapor pressure and enabling cooling. The refrigerant as ammonia and absorbent as water. And second is water lithium bromide cycle. This uses water as a refrigerant and lithium bromide as absorbent, and it's widely used in commercial HVAC chiller. And lastly, chemical absorption cycle. Use special salt, membranes, or chemical reaction for niche application like solar driven system or full cell integration.
Application. And for the application, it is used in off-grid refrigeration, which means it is used in remote or rural areas where electricity is scarce or unreliable. It uses absorption refrigeration because it uses heat as its primary input. This can come from gas burners, solar collectors, biomass stoves, or kerosene. The cycle replaces the electrically driven compressor with a thermal compressor involving components like the generator, absorber, and pump. This allows the cycle to function without electricity. For example, for the systems such as solar absorption refrigerators, which basically are refrigerators that uses solar as its energy source. Other than that is gas-fired camping fridges. Like in the picture, it is a mini fridge that uses gas as its electricity. The thermodynamic advantage would be obviously it avoids the need for electric compressor and uses local thermal energy. Other than that, it is also applied in waste heat recovery. In many industrial processes and engines, waste heat, often low-grade heat, is produced and usually lost to the environment. Absorption refrigeration cycle can utilize this otherwise wasted thermal energy to provide useful cooling, a process known as trigeneration or combined cooling heat and power, CCHP. Trigeneration or cogeneration, as you can see in the diagrams, means that when a fuel is used in, let's say, a generator, it will produce two types of energy, such as electrical energy and heat energy. The absorption cycle works efficiently with low to medium temperature heat sources, which are common in waste heat streams. By converting waste heat into refrigeration cooling effect, overall system efficiency improves, aligning with the second law of thermodynamics, making better use of available energy. An example of the system would be the cooling in industrial plants, air conditioning in buildings powered by cogeneration system, shipboard refrigeration using engine exhaust. The thermodynamic advantage would be it converts low-grade waste heat into useful refrigeration.
And lastly, for the conclusion, the absorption refrigeration cycle is a cooling system that works using heat instead of electricity. It uses a special liquid and gas, such as ammonia and water, to create a cooling effect. This system is very useful in places where electricity is not available, such as remote villages or off-grid areas. By using heat from the sun, gas, or even firewood, the system can keep food and medicine cold without needing power from the electrical grid. Using off-grid refrigeration has many good effects. It helps people in rural areas to store food safely and reduce waste. It also makes medicine storage easier and supports better health. This system is better for the environment because it uses less electricity and produces fewer harmful gases. It also saves money in the long term because it does not rely on expensive electrical system. In conclusion, the absorption refrigeration cycle is a smart and simple way to keep things cool, especially in places without electricity. It is good for the environment, helps people live healthier lives, and makes good use of natural or waste heat.